Thank you for joining us for another video on working on solving trigonometric equations using our various trig identities, our double angle formulas, and our sum and difference formulas. All right. When you're working with these, be sure that you're looking at the equation. All right. You're checking out the equation and determining whether any identity can be used. Right, and then you're going to rewrite, do your math, and solve. Okay, there's a variety of identities. We'll come back and list them out towards the end, but let's go ahead and do our work. All right, so let's say I want to solve here the square root of 3 sine theta minus cosine of theta is equal to 0. So if I look to this, I could rewrite this as the square root of 3 sine of theta is equal to cosine of theta, and say that means that the square root of 3 is going to be the cotangent of theta, because cosine divided by sine is cotangent. If I'm looking on the interval from 0 to 2 pi, I know that the cotangent is going to be positive in the first quadrant and in the third quadrant, right? My reference angle I need to figure out, and that can be figured out by knowing that 1 over the square root of 3 is going to be the tangent of theta, right? Of course, I could also say I know that the cosine of theta over sine of theta is the cotangent, and so that means the cosine ratio has root 3 at the top, and if the cosine ratio has root 3 at the top, I know that my reference angle is pi over 6. And so the solutions here would be pi over 6 as well as 7 pi over 6. Okay. Continuing with this, if we look at our next equation, 1 minus 3 sine x is cosine squared of x. This one's a little bit tougher. And so when we see this with something squared that's cosine and something that's not squared is sine, or vice versa, we can use our identity and say, hey, 1 minus 3 sine x is going to be equal to 1 minus sine squared of x because of my Pythagorean identity. So let's go ahead and move things around. That would give me that sine squared of x minus 3 sine of x must be equal to 0, right? If I subtract 1 from this side, subtract 1, add sine squared of x, add sine squared of x, and I get sine squared of x minus 3 sine of x is equal to 0. So let's factor out a sine of x. So that's sine of x times sine of x minus 3, that needs to be 0. So therefore the sine of x is equal to 0, or the sine of x is equal to 3. However, we know that that's not possible because sine of x is going to go between negative 1 and 1. So this is an extraneous solution. All right, and we know that the sine of x is going to be equal to 0 if x is going to be equal to 0, if x is going to be equal to pi, or if x is going to be 2 pi. However, notice that it's less than 2 pi, so we're not going to consider that as a possibility. We're just going to have these two answers because of the interval that we're given. Okay, looking at another equation here. Right, cosine squared minus sine of theta is equal to negative 1. And once again, in a similar form, using my Pythagorean identity, that's 1 minus sine squared of theta minus sine of theta is equal to negative 1. I'm going to rewrite this and move things around so I can say that 0 is going to be sine squared of theta plus sine of theta minus 2. Right? And if I work on my factoring, that means that sine of theta, let's see, sine of theta minus 1, and sine of theta plus 2 needs to be equal to 0, right? Once again, if you wanted to work this out a little bit different, you could say u is going to be sine of theta, and so that gives me that u squared plus u minus 2 is equal to 0, and then I can use that to help me factor. So sine of theta needs to equal 1, or sine of theta needs to be negative 2. right? We know that we're extraneous. We cannot be -2 for the sine of theta, and the sine of theta will equal 1 when theta is equal to 90 degrees, or in radians, since this is in radians, pi over 2 radians, and that will be my only solution. Okay, so if I have 2 sine x cosine x equals the tangent of x, I can remember that this is a this is a double angle identity. And if I wanted to, and I could say, hey, that means that the sine of 2x needs to be the tangent of x. But for this problem, it doesn't help us when these are two different angles, so we're not going to use that approach, right? But rather, we might say, hey, I have 2 sine of x times the cosine of x needs to be equal to the sine of x all over the cosine of x. Right? So I'm going to go ahead and multiply both sides by cosine of x, and that gives me 2 sine of x times cosine squared of x needs to be equal to sine of x. I'll go ahead and subtract sine of x, and that gives me 2 sine of x cosine squared of x minus sine of x is equal to 0. Factor out the sine of x, that gives me sine of x times 2 cosine squared of x minus 1 is equal to 0, which means that the sine of x needs to equal 0, or cosine squared of x needs to be 1/2. Right? Sine of x is going to equal 0 if x is equal to 0, or x is equal to pi. Once again, 2 pi is not in the interval, so that's going to be the solutions from that one. And over here, if cosine squared of x is 1/2, that means that the cosine of x is going to be plus or minus the square root of 1/2, which means that the cosine of x is going to be plus or minus 1 over root 2. Right? I know that that gives me a reference angle as pi over 4, and I'm going to have all 4 quadrants represented with that reference angle. And so that means that x needs to be pi over 4, x needs to be 3 pi over 4, x needs to be 5 pi over 4, or x needs to be 7 pi over 4. So in the end, I have a total of 6 solutions on this interval where 2 sine x tangent of x is going 2 sine x cosine x will equal the tangent of x. Right, and once again, this is on the interval from 0 to 2 pi. These are a little bit more difficult, right? What identities did we use? Those are the important ones to be familiar with, right? So the identities that we happened to use in this one was sine squared of x plus cosine squared of x is equal to 1, which means that 1 minus sine squared of x is cosine squared of x, or 1 minus cosine squared of x is equal to sine squared of x, right? So those are Pythagorean identities that are very common. Double angle identities that are very common, we know that we have the sine of 2x is equal to 2 sine x cosine x, and that the cosine of 2x has a variety of different ones. The one we used here was 2 cosine squared of x minus 1, but this could also be 1 minus 2 sine squared of x, and it could as well be cosine squared of x minus sine squared of x, right? So those are our double angle identities, right? If we have other identities, right, tangent of 2 theta, we can think of as sine of 2 theta divided by cosine of 2 theta. That's going to be useful more often than not. Right, we also have our reciprocal identities. So as an example, secant of 2 theta is 1 over the cosine of 2 theta, right? And we do have others, right? And then, of course, our sum and difference formulas. So we can say that the sine of alpha plus or minus beta is going to be the sine of alpha sine of beta plus or minus, excuse me, not sine of alpha sine of beta, sine of alpha cosine of beta plus or minus cosine of alpha sine of beta, right? So we have the sine, cosine, plus, minus, cosine, sine, and with the sum difference, cosine of alpha plus or minus beta is going to be given by cosine of alpha, cosine of beta, minus or plus sine of alpha, sine of beta. All right. So important to note the difference with the cosine one. Those are our identities, how we can use problems to solve. And really just have additional practice that you need to make sure that you get. Thank you for your time.